Okay, hi, this is a pig. This pig is named Francis, okay? And this pig has a mass of, let's say, I don't know, 40 kilogram. Big pig, okay? The force of gravity acting on this pig would be equal to mass times gravity. If you don't understand that, watch the weight video. Okay, so 40 times 9.8 is 392 newtons. Okay, so if this little piggy is just hanging out and only gravity is acting on it, I'm sorry, him, Francis, here's gravity, here, pulls him down, he would go falling through the air, okay, and die. But on a lot of situations on Earth, we have him standing on something, right? Like the ground, okay? In a normal boring situation like this, where Francis is just standing on flat Earth, okay? Flat, unmoving ground. And I don't just mean ground, I mean like a table, a shelf. I have no idea. Then in those situations, the force of gravity pulling down is equal and opposite to what's called the normal force, which would be the table, the floor, whatever it is, pushing back up. Okay? So gravity pulls down and the table or whatever pushes back up. I made that one way too long. If that wasn't true, okay, what would end up happening is the piggy, let's say normal force was somehow bigger, then the piggy would start to accelerate upward. If gravity was bigger, the table would break and the piggy would start to go downward. Now, there are situations where the normal force is not equal to the force of gravity. Let's say, for example, we have Francis in an elevator. Okay. There's his little cute pig feet. All right. And let's just say, hypothetically, he was standing on a scale. What scales do is they read normal force. Now, your scale at home reads in pounds because Americans have weird units. It would be far more scientifically awesome if they read in newtons. Let's remember that Wilbur, when he's standing perfectly still, he had a force of gravity of 392 newtons, I think. Okay. So if it's a perfectly flat, boring scale on flat ground, the scale would read 392 newtons. But let's say we were to throw Wilbur into an elevator because he's having a very unpig-like day. So now he's on a scale in an elevator, and we were going to have the scale accelerate upward. Well, in that situation, the ground would be pushing up on Wilbur more than gravity was pulling him down. So he would have a normal force greater than the force of gravity. So situations where the ground is accelerating for any reason, you would see that the normal force is greater than the force of gravity. Later on in this class, we're also going to get into what happens if we had Wilbur on a slide, for example. What would happen to him there? We're going to find that that will also change the normal force. In this situation, you could actually calculate that, and we're going to do a free response question like that later on in the notes. But if the elevator is accelerating upward, the normal force needs to be greater than the force of gravity, so the scale would no longer read his actual weight. It would read something larger than that, okay? So you would see something, maybe like 450 newtons if it was really accelerating. If you remember in class, I actually showed you a video of somebody doing this.